Hello everyone, my name is Leo Rivera. I'm the Director of Scientific Outreach here at Media Group. And today we're going to talk about best practices for particle size analysis measurements. And the things we're going to talk about today apply to almost all methods for measuring particle size of soils. And one of the key things that we always first have to think about when getting ready to start a measurement is the pre-treatment of our samples. Unfortunately, for almost all of these methods, we have to go through this pre-treatment process to correct for a few certain things. So there are four main things that we're trying to do when pre-treating our samples. And one of them is required. And the one that's required is the dispersion. And we need to disperse the soils to get them to separate and repel those soil particles so they're not trying to attract and behave like larger soil particles. And so we typically do this through chemical dispersion and then a physical dispersion. The other things that we may have to correct for are things like organic matter removal. So typically if the organic matter is above 1.5 or 2%, we typically recommend doing organic matter removal by burning off the organic matter with hydrogen peroxide and things like that. In some other cases, we may need to remove the soluble salts and the plasters in the soil because this can also impact the measurement, especially for measurements that are based on Stokes' law. In rarer cases, you may also need to do iron oxide removal. And there are ways to determine if you need to do this, and we have a flow chart that kind of shows you how to do this for measurements with the Pario that you can check out, but these are some of the things that you'll need to think about for pre-treating your samples. So, of course, like I said, dispersion is the most important pre-treatment process, especially for those Stokes law-based methods, but even for some of the optical methods. And this involves two steps. It involves the chemical dispersion, and typically this is done with different types of salt solutions. The method that we use is the 50 grams per liter of sodium hexametaphosphate. And this is based on the methods of soil analysis and Guillen in 2002. There are other salts that you can use, for example, to follow the DIN standards, and you can see some examples of that there. But then the next critical step is the physical dispersion. And this is done using either a shaker table, where we shake the sample in solution for 24 hours or overnight. The method that we use in our lab is the electric mixer method because it's faster, where we have a industrial mixer that's designed for dispersing the samples. This fits both the ASTM standards and fits the methods that are recommended in methods of soil analysis as well. So those are all the things that go into starting your measurement and getting ready for that. But after you've gone through the measurement process, some other key steps to getting good measurements are the post-processing pieces. So one of those post-processing pieces that you have to go through is determining the sand fraction. Unfortunately, especially with the Stokes law-based methods, you can't really determine the sand fraction from the settling because the sand falls out of suspension too fast. You can try and do it, but typically it isn't very accurate. So what we recommend doing is the sieve analysis. And usually the way I like to approach this is starting with wet sieving through a 53 micron sieve to wash away the silts and clays. And then I will dry that sample and then do a dry sieving process with vibrations to classify the various sand fractions. So with that, we'll have a stack of sieves of various sizes where we're vibrating that sample to have it pass through those sieves to get a measurement. Now, there is a certain amount of time and vibration that's needed to get the particles to actually move through the sieves. This can be done by hand in some cases, but it's usually a little bit better done by machine. And so those are just some of the things that you need to think about when it comes to your sieve analysis. Weights are really important here, as you can imagine. The other key post-processing step, and this more so applies to the pipette method and then the Pario Plus method, is the weight of the drainage or the aliquot samples that you would pull. For the pipette method, it's those small little aliquots that you're pulling at each interval. And with the Pario Plus method, it's the suspension that you release at the end of the measurement to try and get our clay fraction. So all of these, we're trying to get more accurate analysis of our clay particles. And one of the really important steps there is an accurate weight measurement of samples that you pull off after oven drying them to burn off all of the water. It's also really important, of course, that you get accurate measurements of not only the full sample itself, but the tare weight of your containers as well, because if you have any errors there, that can result in errors in the measurement. We've talked about the pre-treatment and the post-processing, but there are some other factors that are really key to getting a reliable measurement. And this applies to both a lot of these things that we've talked about. Everything is about mass balance of everything that we're measuring, because we're measuring masses at different times to try and quantify the different fractions of soils that we're measuring. And so if you want an accurate measurement, you need to have an accurate mass of your oven dry material. And in most cases, really what you need is a precision balance to do this, and you need to make sure that you're recording accurate weights while going through this process. Any inaccuracies in your weight measurements, of course, lead to inaccuracies in your particle size analysis. And this, of course, ties back to getting accurate sand percentages. It's really important that you have an accurate estimation of your sand fraction through your sieve analysis, because if you're wrong in your sand fraction, again, that leads to errors in everything else, because that error just propagates through everything else. Along with that, we need an accurate measurement of our mass of the dispersion salts that we use. So really what the key there is accurate preparation of your solution. So typically we prepare a 1 liter bottle to 50 grams per liter for our sodium hexametaphosphate. It's really important that you are accurate in that measurement and everything is well mixed. And then we have a precise dispenser of the solution. That way we have we know we are exactly dispensing 100 milliliters of that solution, so we can have an accurate estimation of that mass of the dispersant that we're using, which for 50 grams per liter, with 100 milliliters, we know that's going to be 5 grams of the dispersing salt. So again, all of these errors can propagate into everything else if we're not careful. This next one is related to temperature. I would say this applies to almost all methods, that it's really important that we have good temperature equilibrium of the water that we're making our measurements in. And so thinking about all of the processes that we're going through, the dispersion, the physical dispersion, those things can create heat in the water. Also, when we're adding water to the cylinders to fill them up to the 1 liter mark for the graduated cylinders for both the pipette hydrometer and for the Pario methods, we can introduce errors because waters can be at different temperatures. It takes time for that to equilibrate. So the best thing to do is, one, have a large container of your DI water that you're using to fill everything in the same room that you're making the measurement. That way it comes to equilibrium with the room temperature. It's also important that your sensors maintained at that same room temperature when you're starting your measurements and doing those things. That way you're not getting any large fluctuations in the temperature of the solution. And then trying to maintain that temperature throughout the measurement. So you can see here an example of a Pario measurement where we have our change in pressure as the particle size as particles are falling out of suspension. But also you can see that we have our temperature measurement there as well. And you see some fluctuations, but they're pretty small. They're less than 0.5 degree Celsius. And that's what we're trying to maintain. Ideally, we are seeing less than a 1 degree C fluctuation in temperature for these measurements to really have good accuracy. So climate controlled rooms are really critical. I know in some places this is more challenging, but ideally we can try and maintain proper equilibrium of the temperature. And lastly, one thing that can result in error, and this is maybe a little more critical in the Pario Plus measurement because we're using that precise pressure transducer, but this can also be an issue for both pipette and hydrometer methods, is avoiding any gas bubble formation during the measurement. We often see this more so when you've had to pre-treat for organics, and sometimes if you haven't properly burned off all of the hydrogen peroxide, that can result in issues. But we can also see it if you don't pre-treat for organics, and there's a lot of organic matter in there. The process of getting all of the particles in suspension can create bubbles in the water, which can also create issues during the measurement. So these are all some things that you're gonna want to try and avoid. So these are some tips that I have for making really good particle size analysis measurement methods. There are, of course, other things that you can try and think about, and there are some other critical factors for some of the optical methods that you're going to want to think about as well, like particle size orientation, some of those things. But these are my tips for making good particle size analysis measurements. Thanks for listening. Good luck with your particle size analysis measurements. Please feel free to reach out to our support team if you ever have any questions. Also, check out the resources we have on our website about using the Pario and some of the other resources we have on making better measurements.